Similar polygons. What you need to be able to do, and this whole chapter deals with this same basic stuff. Write similar statements. We're going to talk about that. Decide if the polygons are similar. We're not going to do a whole lot of deciding if they're similar today. The main thing today is we're going to tell you that they're similar, and then you're going to find missing parts. So this right here is the key thing for today. That third thing right there, and that's probably the key thing for the whole chapter. And then we're going to have two theorems, and those two theorems, we're going to talk about perimeters and areas. When we get to areas, make sure I don't mess it up. Mess it up in every class. And I catch myself and have to go back and redo it. The reason I mess it up, if I'm looking at these two shapes, and I tell you that they're similar to each other, and I tell you this shape is, the length of this side is 4 times as much as the length of this side, which I know it's not, but I'm just making up a number. What's that tell you about the perimeter of this shape? It's 4 times as much as this one. Now, does that work for area? If I look at the area, just because this shape is 4 times as big as this one, does that mean that the area is 4 times as much? It's not going to work. All right? Area is something more. You got to do a little more with it. So when you double, if I gave you a rectangle, say I give you this rectangle and I tell you this side's 5, this side's 6. What's this side going to be? 5. What's this side going to be? 6. Let's find the perimeter. What's the perimeter of that? 22. Areas. Anybody remember the formula for area of a rectangle? Length times width, base times height. Means same thing. So in this case it'd be 30, right? Now if I told you I took that rectangle and I tripled the length of each side, how long is this side going to be?
24.
Tripled. 18. How long is this side going to be? 15. How long is this side going to be? 18. How about this side? Get your calculators out. Make sure you got them out in the whole class so that you can help me out. I didn't check them today, but I will. What's the perimeter?
66.
Does everybody agree with that? Now, look at what happened to the perimeter. You went from 22 to 66. What did you do to it? Times it by 3, right? Times it by 3. Now, when we do the area, length times width, what's 18 times 15?
270.
Did that get times by 3? No, it actually times it by 9. All right? So it's different with area. And the theorem that we go over when we get to that is going to take care of that difference. Blake's, is there a problem there?
No.
Go ahead and start copying this down. Does anybody remember this symbol from earlier this year? What it meant? That's what it means now. What did it mean earlier? Remember when I had something like this? Say it again.
Not.
It meant not, right? It meant not. Or negation. Why we use the same symbol for negation and similar? No clue. All right? It's just ignorant. But we do, so. So you're going to have to, Braden's going to have to remember when he sees it written out this way, what's that symbol mean? Similar. When he sees it written this way, what's it going to mean? Not. So maybe you got to be able to make sure that you can do whichever one it is, especially for the final when we have both things on the final.
When are we getting our test back?
But like, what if someone takes it like similar
Do a similar P. That would, right. It wouldn't make sense, would it? P similar to what? So that it shouldn't. So you should be able to tell that this doesn't mean that. Blake V. See that chair way in the back that I'm getting ready to push back in the corner? Right.
I was asking about the test. I swear to God.
She asked me when we got the test, and I said, you said it at first.
I know, that's why I didn't answer.
I called that too.
Maybe do it after. That's all I heard.
Thank you, Braden. Two things have to occur when you have similar polygons. Earlier this year, we talked about congruent polygons. What were the two things that had to occur when two polygons are congruent? They have to be what? Same, there's two words. Same size and the same shape. Similar is a little different. Same shape, but do they have to be the same size? No. They could be, all right, but they don't have to be. So all those triangles that we proved were congruent earlier this year, were they all similar to each other also?
Yeah.
Yeah. A lot of you getting stuff mixed around with the squares and the rectangles. All squares are rectangles. Are all rectangles squares? No. You got to make sure you can say that one way but not the other. Same thing here. All shapes that are similar are also, all shapes that are congruent are also similar, but not all shapes that are similar are congruent. How many sides would this shape have? 5. So what is it?
Can you draw that picture?
Yeah, draw these, yeah. It's a pentagon. So we got this pentagon, this one would be a pentagon, this tells us they're similar. As soon as you see the names, you should be able to do 90% of the work that we're going to do. So without even drawing these pentagons, without drawing these two pentagons, I should know that in the first pentagon, angle A is going to be the same as what in the second pentagon? Angle Q. See how they match up? Segment AB is going to match up to what in the second one? QR. All right? You should be able to match them up that way. When we're looking at similar polygons, these are two key things. These two things are probably the key for today. Number one, corresponding angles are congruent. The angles that match up have to be exactly the same. So if I tell you angle A is 70 degrees, what do you know about angle Q? 70 degrees. It's exactly the same. All right? There is no difference. The angles don't get bigger or smaller. If one of them is 70 degrees, then the one it matches up to in the other figure, 70 degrees. The sides have to be proportional. About 90% of the work that we do for this chapter, every problem, you're going to start off this way, drawing a fraction bar, an equal sign, and a fraction bar. Do not do this. Those aren't fraction bars. Those are slashes. I don't want to see any slashes. I know Logan wouldn't do that because he's a man, right, Logan? This is the female way of writing so it looks cutie. All right? Fraction bars. Sorry, Cheyenne, but for this chapter, you got to be a man. Write stuff like a man. Fraction bars. How come I don't want you to write it with the slashes?
It's hard to cross.
Exactly. It's hard to cross multiply. You write something like that, it's hard to cross multiply. It's hard to tell what you should multiply. All right? When I write it this way. Is it hard to tell what needs to be multiplied together? No. These two, those two. It's easy. So don't use the slashes. Use fraction bars. Derek, can you handle that?
Bro, you got no good
On this last thing, for these to be congruent, angle N, or I'm sorry, for these to be similar, angle N is going to be congruent to what in the other one?
E.
Angle E. Does everybody see that? If they mark them for you, then just match them up. What do you have to do to this red shape to get it to match up to that black one?
Rotate it 90 degrees.
Rotate it about a quarter of a turn so it matches up. Does everybody see that? So E's going to lay on top of N. B's going to lay on top of what? T. L's going to lay on top of H. So on, so on, so on. So let's name these two. Name that first pentagon for me.
NTHSB.
What did Josh have to make sure they did? Went around it either clockwise or he could have done what? Counterclockwise. Did he have to start it in? No, he could have started anywhere. And we're going to say that that's similar to
EBLAZ.
EBLAZs. Everybody see that? You got to make sure that they match up. Got to make sure that they match up. If we know that they match up that way, then segment NT is going to match up to what segment in the other pentagon?
EB.
Everybody agree with that? Now those are going to be special to each other. That segment and that segment match up, and we're going to talk about what that means to match up here in just a second. All right, scale factor. Does anybody remember what letter stood for scale factor when we did dilations earlier this year?
K.
K. Why? Why is it K?
Because some math person decided to make it K.
Exactly, that's it. Same reason that slope. Why is slope M? No clue. Some math person, probably it's what their name started with. They thought they were important, so they wanted their name to be part of it. I would have. I'll have to have my initial VA letter for some math term to think I'm important. I already know I'm important. Does anybody remember when we were doing scale factor? If your scale factor is 3/5, is the shape getting bigger or smaller? Smaller. Anything less than 1, shape's getting smaller. If the scale factor is 5/3, is the shape getting bigger or smaller? Bigger. It's an enlargement. Anything larger than 1 for a scale factor, the shape's getting bigger. Now, when we do this stuff, and I talked about this earlier this year when we did dilations, when we do this, if the scale factor is 3/5, and Justin puts on his paper 5/3, am I going to mark it wrong? Probably not. All right, but if they're saying you're starting with this original shape and changing it to this other shape, you got to know if you're getting bigger or smaller, so which scale factor you're going to use. If we were getting smaller, we'd use this scale factor. If we were getting bigger, we'd use this scale factor. So you got to be able to pick that out. Now, I'm not going to much care, but if there's a multiple choice problem on the next test and it says find the scale factor, is it probably going to have both those answers on there? Yeah, and only one of them is going to be correct because they're telling you that this is the original shape, this is the new shape. And you got to know, hey, was I getting bigger or was I getting smaller? And if it's on the EOC test, you really got to know then, because whoever's grading it's not going to understand that the scale factor of 3/5 is basically the same thing as the scale factor of 5/3, just going backwards. Yep. Looks like you're 8 passes now. Anybody else think that?
What? How's it get?
I got to figure it out. Hurry so you don't get lost. Splash some water and come back quick. Just kills me. I went in there earlier and people walked in after me. I used the restroom. Those people just stood there and waited. I washed my hands. They were still standing there waiting. So I just stopped, waited, and they walked out. I'm like, Devin, is that what you do? Do you walk in, just hang in public restrooms?
No.
You know what? You know.
We go to the restroom. You're a party pooper.
You know what people usually call you if you go hang in a public bathroom, just like that for no reason?
Restroom partier?
No, a pervert.
I knew that was coming. I knew. I wasn't thinking
Damn.
that way, but I was thinking that.
Am I wrong though? In certain cases,
Yeah, it's just, I mean, as long as you're not like invading
Why,
space.
why would you be hanging around in the bathroom?
I'm still recording.
That's exactly
But
what
I
doesn't
ain't in
make
my
any sense.
bathroom because I know it's. He's still recording.
Actually, there's like one glove. One on
Like, watch this.
With proportions. With proportions. Take that home and you guys can let your folks watch this video and they'll probably agree with me.
Okay.
3 different ways to write a proportion. Of these 3 ways, this is the way that we're going to use the most because that's the way you're used to seeing them. All right? So something over something equals something over something. Using the fraction bars, not slashes, fraction bars. This is the way I would rather see them written because that's more mathematical. And I'm going to explain why here in a minute. This one, you see stuff like this a lot when you're reading something, maybe on a map or something. Okay? 7 miles to 1 meter or something, whatever. 1 centimeter. When we go to solve these, we cross multiply. When you cross multiply, the actual mathematical way to do this that you never learned when you learned how to do proportions before is you actually multiply the extremes together and you multiply the means together. And I'm going to write this up here and I want you to write this down in your notes there. When you're doing a proportion, you have 4 terms. Mathematically, that's called the first term. That's called the second term. And guess what this one's called? Good, Justin. Third, make sure you let your folks hear that so they'll forget all about what I said and say, hey, how are you? So you have those 4 terms. First, second, third, and fourth. The first and the fourth are called the extremes. The first and the fourth are called the extremes. And the reason I like this one better, if we're dealing with extremes, what's it mean for extreme? What's the word extreme mean? Maybe massive. What if I said, here in a few minutes, we're going to pass back the test, and I say, Logan, you got an extreme grade,
That could be low, too.
and Justin got a extreme grade. What's that saying? Does that mean that they know that their grade's high?
No.
No, not necessarily, because what else could it be? Could be extremely low, right? So it's the low and the high, or it's the far, the spread. So when I'm looking at this, when I look for the extremes, A, B, X, and Y, which ones are the extremes? A and Y, because they're the farthest ones out. All right? The means, what's the word mean tell you? Middle. That's what it tells you in math, middle. So looking here, which ones would be the means? B and X. Here, it's the second and third terms. The second and third terms, second and third are the means. First and fourth are the extremes, second and third are the means. What do you do to solve this? Cross multiply. A lot of you probably do this and use the little bubbles and circle the stuff. I won't ever do that. When I have a problem, I always do it this way. Just draw a little line there. Some of you probably have done it that way too.
You want to take it off if you do it like that, right?
The bubbles, no. Alright? But I'll just do it this way. Those are the two. We got to multiply those two. We got to multiply those two. When you're doing this, you've got to be real careful, because if you don't pay attention to what you're doing, I know what's going to happen. When you multiply here, you got A times Y, and then you got B times X. What'd I forget? The equal sign. Guarantee you there's going to be several of you forget your equal sign. You got to have that equal sign in there. It's the extremes multiplied together. The extremes multiplied together equals the means multiplied together. All right, write this down. Draw that. Draw the two triangles. We're going to work these problems out, or work this problem out. Find all the missing parts. How many parts does a triangle have? Be careful before you yell out 3, because that's not the right answer. 6. It's got 3 sides and 3 angles. So if we have 2 triangles, how many parts is it going to have? 12. 12 total parts. Yeah. A little bit, just follow along, write this down, you'll catch up. Have faith in your Blake. Somebody read this to me.
If triangle ABC is similar to triangle FKH, find the missing.
Now, before I even start looking at the triangles, angle A, I know angle A has got to be congruent to what other angle? Angle F. Does everybody see that? You can pick that out from the names. Angle A, angle F have to be exactly the same. How about angle H? What's it got to be the same as? Angle C. How about segment AB? Segment FK. Are they going to be congruent? They're proportional. All right, that's what we're going to do. We're going to set up those proportions. We want to find the missing parts. We're going to set up these proportions and find all this different stuff. First, let's start with this triangle. Let's just list all the parts. Tell me one of the parts, one of the angles. Angle A. What's another angle? Angle B. Another angle. Angle C. Tell me a segment in this one. AB. Segment AB.
AC.
Segment AC.
Segment BC.
Segment BC. That's all 6 parts in that triangle. Let's go ahead and write down all 6 parts in the other triangle. Name me an angle.
H.
Angle H. Angle F. Angle K. Is it all right to name all these angles with one letter? Yeah, in these 2 pictures. Sometimes it's not. Sometimes you might have to name it with how many letters? 3. What's the, give me a segment in this second triangle.
HK.
Segment HK. Segment FK. Segment FH. Sorry, I got mine a little close together, so it doesn't look very good. We're going to find all those parts. Let's go back over here, because we already know some of these parts. Let's just write them in. Name me one thing that we already know.
Angle A is 50 degrees.
So angle A is 58 degrees. Let's go ahead and write that in.
Angle B is 90.
Yeah, I would. Angle B is 90.
Angle C is 32.
We don't know that. Tell me something else we know. Josh is jumping ahead too much.
AC is 20.
Segment AC is 20. So let's write it in.
AB is 12.
AB is 12.
I cannot see the other 16.
So we know those. Josh is wanting to put angle C in there. He's going to explain to us here in a minute how he found that. And then we'll decide if whether he's right or not. About angle H, do I know it? About angle F? K? Segment HK? What is it? Segment FK? Do we know it? Segment FH?
Is it time to get my
Hold on. So now, we're going to use this. Easiest thing to find apparently is angle C because Josh found it already. Explain to me how to find angle C.
Add 58 and 90, subtract 180.
58 plus 90. What is that, 148?
Yep.
Subtract that from 180. How did Josh know to subtract it from 180? Three angles of a triangle have to add up to 180. What's it come out to be?
32.
This angle's 32. We know all the parts of this triangle now. Let's come over here. What's the easiest thing to find?
Sides.
The sides? Something easier than that. The angles. Because what do we know about the angles?
Well, then if it's like.
Well, don't they add
They're the same, right? They got to be the same as the other triangle. Even though this triangle's smaller, the angles that match up have to be congruent, have to be the same. So let's look at angle H. What angle does it match up to in the other one? Angle C. So what's it got to be? 32 degrees. So it's right in there. These are all the things that we found on our own. We found that. found this. I'm going to circle this all together here in a minute. About angle F, what's it match up to? Angle A, so what's angle F going to be? 58 degrees. Angle K matches up to which angle? Angle B, so what's angle K going to be? So we found all that. Now the angles we know are the exact same. The sides have to be proportional. So what we're going to have to do now is set up a proportion. When you're setting up these proportions, what you want to do, you want this first ratio to be a number and a number, if at all possible. So a number and a number, if you can get that, because we want to make it as easy on ourselves as possible. Which question, Brittany?
I'm confused. Why would you set up a proportion when you can just divide them?
Because not all problems are going to be as easy as this one. So I'm going to show you how to do the process so that you know it on the harder problems. As a matter of fact, none of the problems are going to be as easy as this one. This is one I made up just to make it easy to start with. So on this, we're looking at it. The first thing you probably want to find is you probably want to find your scale factor. Because if you find the scale factor, that's going to be your first ratio here. All right? So pick me out two sides that match up that we know a number for both of them.
16 and 8.
Does everybody agree with that? This 16 matches up to that 8? Now probably if we reduce this down, what's that reduced to? 2 over 1. What's our scale factor then? That's what you guys have been trying to tell me, right? What are you doing? So to get to here, we're multiplying by 2. So probably in this case, the scale factor is not really 2 over 1, because if we're starting here and going to here, and it should be 1 over 2, it'd be flipped around. All right, it'd be flipped around. I don't care. If you leave that as the scale factor, that's fine. You could use that scale factor as your first fraction every time. Sometimes it's going to be easier to use that. Sometimes you might just want to leave it what it is. You might not want to reduce it down. Okay? I'm going to put 16 over 8 here. Just so I can make you use your calculators. So now we got 16 over 8. Which other side are we trying to find over here in this one? KF. So that's this. Well, we don't have anything for KF.
X over 12.
So let's make it X.
12 over X.
What's it match up to? AB. So what goes right here? 12. What goes here? And you've got to make sure. This came from the first triangle, so when you do it, when you match it up, that has to come from the first triangle. This came from the second triangle, so when you match it up, this has to come from the second. They gotta match up correctly. We cross multiply. What's 16 times x?
60x. 96.
8 times 12 is 96. Everybody agree with that?
96 divided by 60.
Divide both sides by 16.
What? I didn't do anything.
What's 96 divided by 16?
6.
6. So how long is segment KF? Or FK, either one, same name. What are we going to do to find the other one? Same thing, set up a proportion. Now watch, instead of using 16 over 8, we said 16 over 8 reduces to 2 over 1, and this is what Brooklyn's saying. What matches up over there? 20 over, I'm not going to use X, we'll call it Y this time just to make it different. Could you look at this and just solve it? Probably so. Sometimes you can do that. Sometimes you can just look at it and say, 2 compares to 1, the same as 20 compares to what? 10. So how long is this side right here? 10. Did we find all the missing parts in both those triangles? Gotta be able to do all that. What do you know about the corresponding angles? They're the same. They're congruent. They're equal to each other. Exactly the same. Corresponding sides, you have to do the work. Set up the proportions. Scale factor. Pick any 2 sides that you know a number for both of them. Set up that match up. Set up a ratio and reduce it down. Again, for this scale factor, I would probably accept 2 over 1. What's the other answer I'd probably accept? 1 over 2. Same scale factor. All right? It's just, I didn't tell you which way we were going. Did I say this was the one we were starting with and this was the new one? So we need to know which way we're going. A lot of times in the books, in this book, they put an arrow there. So that's telling us, hey, we're starting here and going to here. So which one of the 2 scale factors would be the correct one? 1 over 2. We'd be making it smaller. All right, write down this. Similar polygons, perimeter theorem. Draw those 2 pentagons that I have there. Perimeter's pretty easy because it's the exact same thing as dealing with the sides. So if you're dealing with perimeter, and I hate to even say this because my last class got all confused, there'll be a problem on the next test where a lot of you will get the answer 59.6. And I'm going to take points off for it. Because to get 59.6, what you would do, you'd use proportions and go through and find this side, find this side, find this side, find this side, then add them all up and get to perimeter. When you could have just used this proportion and done a proportion once and found the perimeter of the second shape. And if you do that, if you use this proportion on that test question, your answer will come up to be 60 exactly. It'll come out even, come out a whole number. Because if you find each one separately, then you end up rounding stuff off. All right? And as you round stuff off, is everybody going to round everything off exactly the same? Probably not. Okay? But if you use this, it makes it easier, because now all we got to do is one proportion instead of 4 different ones, then add them all up. It says find the perimeter of QWERT if QWERT is similar to pentagon ABCDE. Name me a pair of sides that match up in these two. QW and AB. That's true. Do we know those, both those?
ERC.
Give me, exactly, and that's what I was getting ready to say. Give me 2 sides that we know a number for both of them. ER matches up to,
C.
do we know a number for both those?
Yes.
That's the ratio we want first. 8 compares to 3. You want to pick ones that you know numbers. Do you want to put variables in if you don't have to, Justin? Probably not. Yes.
Do you have a common center?
Yes.
Did he come down to find out?
Wake up.
Sure.
Thank you.
I didn't get out of it.
Wake up.
But there's no eggs and bacon things, but it was leaky.
Now, when we do the second one,
What did we do?
we want perimeter of the first shape. How are you going to find the perimeter of this first shape? Add them all up. Get your calculator out and add them all up. My last class told me 6 different answers, Miss Pease, because they couldn't add.
34, 38.
Cheyenne said 45, I heard. 45? Anybody else get something different? 45? Is that what we're going with?
Yeah.
So the perimeter of this one is 45. When we go to set this up, perimeter of this first shape, where does it go? Top or bottom? Top?
Yeah, top.
Because it matched up with the 8, right? Those both came from the first shape. What's going to go on bottom?
X.
X. I'm not going to use X.
W.
I'm going to use P. Why would I use P? Perimeter. Use something that makes sense to the problem. When we were doing these problems, when you did these problems on those worksheets, how come I use P right here? Pineapple. How come I use dates right there? Height. Use something that makes sense so it helps you remember what you're trying to find. I cross multiply. What's that give me? Multiplying them extremes.
AP.
AP equals 135 when you multiply the means. Now what? Divide by both sides by 8. These cancel out. What's P? 16.9.
Yeah, that's what it runs into.
So what's the perimeter of this shape? 16.9. Is it all right for the perimeter to be a decimal like that?
Yeah.
Yes, no, maybe?
Yeah.
Yeah, it doesn't have to come out whole. How long is segment AB? No thinking about it. Just tell me. How long is segment AB?
No idea.
No idea. How long is segment AE?
No idea.
No idea. Now, is it 4? No, because are they exactly the same? No. Do we care how long segment AB is?
Nope.
No, they didn't ask us to find that. All they asked us to find was the perimeter right there. That's all they wanted. That's all we needed. We didn't need all those sides. Next one, if you're dealing with area, this is probably the one that you'll want to use the most. These 2 formulas, these 2 proportions are the same proportions, just written in different ways. If you have this, and you should have learned this in your algebra class at some point. Let's say you have 3 over 4, that fraction squared. You could take 3/4 times 3/4. Most of you don't like fractions, so you probably wouldn't want to do that. Or you could just do this. Square the top number, square the bottom number. Means the same thing. So it'd be 9/16. That's what this one's telling you to do. And that's probably the one you want to do most of the time.
Make sure you get
Yeah. What should happen when we're finding the area of that second shape? If we look at the first shape and say, oh, this blue one is about 3 times bigger than that green one. So should it just go down by 3 times? Should we be able to divide it by 3 and get, oh, it's about 40? No, that's not going to work. Area doesn't work that way. When you're doing any of these, make sure your answer makes sense. All right? If I'm doing this worksheet problem here with the cans of pineapple, and we're going down through here, and it says Sally bought 1 can of pineapple for $2. Joe's got $10. How many cans can he buy? If I come up with 50, does that make sense that Joe can buy 50 cans for that $10? That doesn't make any sense, does it? So make sure your answer makes sense. So using these proportions, I set up my proportion here. This says area of the first shape. Do we know the area of the first shape? So we put 120 right there. Area of the second shape. Do we know the area of the second shape? That's what we're looking for. So I'm going to make it A. Why might I make it A? Stands for area. How come I made it a big A and not a little a? As soon as I make a little a, what's going to happen? We'll think it's a 9. Derek, you'd never do that, right? You never think that your little a is a 9? Then we pick 2 sides that match up. The only ones that they gave us this time, 10, and it matches up to 3. Now here's where I messed up all the time. We got to make sure that that's in parentheses, and we're going to do what? Square. I'm going to rewrite this up here so I don't have to bend down. That's 120 over A equals, and then just do the math. Square each one. What is 10 squared? 100. What's 3 squared? Does everybody understand that? Braden, did I lose you? So look, all I did here, Braden, this is what this proportion, this theorem tells us to do. Well, instead of having 10 over 3 times 10 over 3 and dealing with the fraction, all you really got to do is take that 2 and give it to that top number and give it to that bottom number. Give it to both of them. So 10 squared, 3 squared. And 10 squared gave us 100, 3 squared gave us 9. We cross multiply. How come I'm doing the means first this time? It's got the variable in that, we put the variable on the left, and sometimes that helps some of it. 180 equals 1080. Do I write it that way? What did I forget? Gotta put the equal sign in there.
Do we have to write it like that?
Divide both sides by 100. Cheyenne just asked, do we have to write it like that on the test? See that right there? 1 point. See this? A second point. This, third point. Then your fourth point would be A equals what? 10.8. Now what's our units? Because that's not our answer. 10.8 centimeters squared. How come centimeters squared? It's an area. Find the area. Area is always going to be in square units. Volume is cubed. How long is segment NT in this blue triangle? No clue. How long's segment BL in this one? No clue. Do we care? No. All we had to do was find the area. Did we find the area? Now, usually to find the area, you'd have to use these formulas I'm getting ready to put up here. Anybody remember the formula for area of a triangle? Good. Half base times height. What's the height in this blue triangle? No idea. What's the base in this blue triangle? No idea. Do we care? No. So to find perimeter, you add up all the sides. To find the area of a triangle, that's the formula. Area of a rectangle, that's the formula. What's the other formula for area of a rectangle? Oops. What's the other formula for area of a rectangle? We got base times height. Maybe you guys aren't old enough. Maybe they've done changed it by this time. What's the other formula to find area of a rectangle? Length times width. Length times width.
I've been thinking that the whole time in my head, but I didn't want to say something.
Say, you know, every time you say something wrong, I say, "Nuh-uh, Braden, you dummy." I'll never say that.
And you're correct.
A lot of books changed it to base times height. The reason they changed it to base times height is so it goes along with everything else instead of doing length times width. Perimeter, you add up all the sides. I wrote these two down just to refresh your memory. It should be something that you already know. If not, hopefully you'll know them now. Next thing I need you to do, get out a clean sheet of paper and get your books out. Open them up to page 423. 423. This that we're getting ready to do, you're going to turn in. 423, 1 through 10 and 19. The quicker we get it done, the better off for you. Number one, it's 3 points. This is what we talked about, Justin. You don't need any free points, right? Everybody else does, though, Justin, because they're not as smart as you are. These are 3 points. Write it down. We're going to go through it together. And the quicker we get done, the better off for you, because then I get to hand your test back quicker.
I was asked the same question.
Why don't you?
So go get it. Because that way I have a book.
My bad.
No, you got to take it home with you so you can use it
I usually use the one online.
next year. You can leave it in here next year. Make sure you remind me of it. No.
On my bag, you can't.
It's probably a video. It's going to get me in all kinds of trouble. 423. Clean sheet of paper. Looking at problem 1. When Blake gets back, if anybody likes him, you'll help him tell him what the answer to problem 1 was. Filling in 2 blanks, so you're going to have 2 answers. Complete the sentence. For 2 figures to be similar, corresponding angles must be what? The angles that match up got to be what? Congruent. The angles got to be congruent. That's the first blank. The corresponding side lengths must be what? Proportional. Proportional. So angles are congruent, sides are proportional.
So that's what we write down.
That's what you write down.
For the whole number one?
Yep.
So
congruent, comma, proportional.
Alright.
Number 2. What is the scale factor of those two triangles? First of all, are we getting bigger or smaller? Smaller. We'll call this A, then we're going to call the other part B, then C, then D. Because one of them doesn't go along with the rest of them. They want to know which one doesn't go along. You can just say like the second one, or the third one, or the fourth one, or the first one, or whatever it is. Getting smaller. If they're getting smaller, tell me what the scale factor is going to be. 1/4. Everybody agree with that? Pick any two sides, match them up, and then reduce it down. Which two sides did you pick, Justin? So the 5 and the 20. So 5 over 20 is what Justin did. 5 over 20, what's that reduced to? 1/4, that's our scale factor. So what that scale factor is telling you, for one part in the smaller triangle, it's got to match up to how many parts in the bigger triangle? 4. Part B, what is the ratio of their areas? So do we know the areas of those two? No, no clue. But how would we find it? What would that last thing tell us to do? Pick two sides. I'm sorry, next to last thing. Pick two sides, match them up, and then do what to it? Squared. What is 1 squared? What's 4 squared? Those two go together? I'm guessing one of these two is going to be the one that doesn't go with it, because usually the way these problems work, you get the same answer, right? And those are the ones that go together. Part C. What's the ratio of the corresponding side lengths? So if we pick two sides and match them up, what's the ratio? 1/4. We already did that for scale factor, right? That is the ratio of two corresponding sides. Let's do D just in case we messed up somewhere. What's the ratio of their perimeters? Remember looking at my two rectangles here, if I had these two rectangles, and I told you this side that my hand's on was 1/4 of this side, what's the perimeters gonna, how are they gonna compare to each other? 1/4. Which one doesn't go with the rest of them? That one's the one that doesn't go with the rest of them. Open your eyes. Number 3. Give me just a second to draw this.
We don't have to draw it, right?
Nah, you really don't need to draw this. Whole lot to write on this one though, because they want us to do a whole bunch of stuff. What's the first thing the directions tell us to find?
Scale factor.
So first thing we're gonna find is K. That's supposed to be a K. My pen's not writing where I think it ought to write. That's better. How do we find the scale factor?
Take two.
Pick two sides. Now, the thing I'm going to tell you, do I want to pick 4.5?
No.
Do I want to pick 6.75?
No.
Why not?
Because it's a struggle.
They're decimals.
Decimal.
No reason to make it harder than it has to be. Pick me a side.
CB and M.
Those two match up, right? So 6 matches up to 8. Take your calculator if you don't like reducing fractions. If I'm using Cheyenne's calculator here, if you got one of the small calculators, it's got an ABC button on it. You just use the ABC button, hit equals, and it reduces it for you. If I have the big calculator, you got to do this. 6 divided by 8. Hit the math button, and the very first thing says fraction. Hit enter. And then what that's telling the calculator is it's going to give your answer as a fraction. What's it tell us? 3/4. So what's the scale factor? 3/4. That's our first answer.
This is number 2.
It's number 3. Oh no. Didn't mean to erase all that. So scale factor is 3/4. What else they ask us to find?
List all
And I'm not
figures,
redrawing.
congruent angles,
So we want all the congruent angles. Pick me an angle in the first one.
A.
Angle A. What angle, be careful, what angle does angle A match up to in the second one?
L.
Angle L. So what do we know about those two angles? They're congruent. So write it that way. Angle A is congruent to angle L. Give me another pair of angles.
Angle C is congruent to angle N.
Angle N.
Uh-huh.
And give me the third pair of angles.
Angle B is congruent to angle N.
So we got that. We got that.
ratio of all of the corresponding side lengths.
Now, normally I wouldn't do this. That's a proportion, right? I'm going to actually do this and give it 3 ratios. You don't want that because how many equal signs do you want in one problem?
1.
1.
How would you cross both?
You can. And that's why I don't even like writing it this way, but it's going to make it easier on us. So you can't actually use this mathematically, but what we can do with it is just answer the question that they're wanting. So give me 2 sides that match up. You already gave me 2. What were they?
AB and LN.
Give me numbers.
6 and 8.
6 and 8. We already knew that those 2 matched up, right? We used that for the scale factor. Give me 2 other sides. Now, what you got to be careful of is, did the 6 come from the first triangle or the second triangle? First. So everything on top here has to come from the first. So give me a number from the first one.
4.5.
4.5. What's it match up to in the other? 6.
6.
Give me another number from the first one.
6.75.
6.75.
9.
What's it match up to?
9.
9. That's all those ratios. What should be true about all those ratios?
Congruent.
They should all be the same. We said that this first ratio was 3 to 4. Some calculators, I'm not sure why Josh's doesn't do it. Can I borrow your calculator? If I use Sam's calculator here, some will let you use the ABC button on this one, some won't.
Is that the cheating one?
Well, I just did it and it worked.
Did it?
Yeah. But earlier it wasn't working.
So if I do this, 4.5, ABC button, 6, hit equals,
Mine's a syntax error.
4.5, see some of them will say that. ABC button, 6, nope, yours won't let me do it either. So a lot of them won't let you put a decimal in a fraction. So what you need to do to get rid of that, times it. If I bump that, if I wanted to bump that over 1 space, what am I timesing by? 10. So it ended up being 45 over, if I times the top by 10, what do I got to do to the bottom? Times it by 10. Now take your calculator and do 45 ABC button 60 and see what it reduces that to.
3/4.
Yeah, and that's another thing you could do, but we don't want a decimal form, right? So you could do this. If you didn't want to do multiply by 10 there, I didn't even think about that. You take 4.5 divided by 60, hit equals, not by 60. 4.5 divided by 6, hit equals, and it gives me this. Sometimes you'll know 0.75 is the same as what as a fraction? 3/4. The other thing you could do if you don't know what it is as a fraction, Sam's calculator here's got this button. It says F arrow D. What's that telling you? Fraction to decimal or decimal to fraction. So if I hit second fraction to decimal, it changes it to a fraction for me. So you could do it that way, Josh, instead of multiplying by 10. What's this one gonna come out to be? 3/4 also. All of them end up being 3/4. Number 4. Same idea. So this time, be careful though. What's different about the two shapes? What do you gotta do to the second shape?
Gotta flip.
It's gotta sort of spin around and flip around, right? So you gotta make sure that when you match them up. Let's find the scale factor. Pick me two sides.
Like EF and RQ.
Give me the numbers.
3 and 1.
3 and 1. Everybody agree with that? Will that reduce? So that's our scale factor. 3 to 1. Actually, that's probably backwards. It should probably be 1 to 3, but I'd accept either one. Now let's do the angles. How many angles are we going? How many pairs of angles are we going to have this time? 4. Give me one angle from the first shape. D. What's it match up to in the other one? Be careful. P. Is everybody in agreement with that?
Flip it around again.
Yeah.
You gotta flip it around, right? Give me another angle in the first shape.
E.
Looking at that first shape,
Q.
angle E is gonna be congruent to what angle in the second one?
Q.
Does everybody agree with that? Give me another angle in the first one.
F.
What's it congruent to?
R.
Come on, Ken. And the fourth pair of angles?
Angle G is congruent to angle S.
G and S. So that's all the angles. Now we want to do the sides. How many fraction bars do I need this time? 4 of them, right?
Oh, my. Does it like depend on how the sides come out?
Yep.
We already matched up one of the pairs of sides. What was it? 1/3 or 3 to 1? I'm going to do 3 to 1 just because that's what I have written up here. Match me up another pair of sides.
6 to 2.
Does everybody agree with that? 6 to 2? Those match up?
12 and 4.
12 matches up to 4. Everybody agree with that? 9 to 3. Now, what should be true about all those? They should all reduce down to 3 to 1, do they? Yeah. 2 will go into 6 3 times, 2 will go into 2 once, 4 will go into 12 3 times, 4 will go into 4 once, 3 will go into 9 3 times, 3 will go into 3 once. So they all reduce down. It's the same. Number 5.
Says the polygons are similar, find the value of x.
So now we're just looking for x. These are the ones that we're going to do the most of. First thing you want to draw. 2 fraction bars with an equal sign. Find me 2 sides in those 2 polygons, whatever they are. This time they're triangles, right?
18 and 12.
18 matches up to 12. Everybody agree with Josh? Katie, do you agree with Josh just because he answers every question and he seems to be right most of the time? Or do you agree with him because you actually seen it and thought it was right?
He's smart.
A?
X and 20.
I hope not, Miss Pease. I hope that you're actually...
X and 20.
Now we got 18 that matches up to 12.
X and 20.
Remember did this come from the first triangle?
Yes.
Yeah.
So we want this to come from the first triangle.
X.
X, does everybody agree with that? What's it match up to?
20.
20? Does that come from the second triangle?
Yes.
We cross multiply, what's 12 and X give us?
12x.
Equals, cross multiply this way, 360.
X.
Divide both sides by 12. What's X equal?
30.
Now make sure that that makes sense. Does it make sense for that side in that triangle to be 30?
Yes.
Does it look like it's the longest side in that triangle?
Yeah.
Yeah. Does it look like it should be about 30? Yeah, maybe. What's another thing you could check in that triangle? If your triangle looks like this, we did this earlier this year. This side's 21.
Oh, it's the third side thing.
This side's 18. What do we know about that third side?
It has to be less than 21 and 18.
Add those two together and it's got to be less than 39, right? What's it got to be bigger than? What do you do?
Subtract.
Subtract them. So it's got to be between 3 and 39, was it?
Yeah.
So if you come up with some crazy answer like 150, you could say, that doesn't work for that problem. Number 6, same thing, right? Match them up for me. Let's go quick.
16, 12.
16 matches up 12. Everybody agree with that?
Yeah.
I think this one you got to spin it around or something, don't you?
Yeah, it's X and
Yeah.
18.
X and 18. Everybody agree with that?
Mhm.
Yes?
Yes.
Could we reduce 16 over 12 down? Yeah, and I might reduce this one down, and I'm going to show you this. You can go ahead and cross multiply and do it that way if you want. I know that 4 will go into 16 4 times, 4 will go into 12 3 times, and I could reduce it down, and that's not going to change our answer. And the reason I might do that is because it's easier to do the multiplication. I know that 4 times 18 is 72. I can do that in my head. I can't do 16 times 18 in my head. All right? Divide both sides by 3. I can do this division in my head too, and I get 24. Is that the answer you got if you did it out using this?
Yeah.
So if you reduce it down and get that scale factor 4 to 3, sometimes it makes it a little easier to do the math. Number 7.
6 over 12.
Does everybody agree with that? 6 over 12.
Yeah.
X over 22.
X over 22, is that right? This one here I would for sure reduce down. What's 6 over 12 reduced to?
Half.
1/2. So I'm looking at this, I say 1 compares to 2, the same as X compares to 22. And Justin's going, well, you just told us a few minutes ago that we have to show our work. That's true, but if it's something like this, I'd probably not care so much. How is 1 going to compare to 2 the same as some number compares to 22? What's going to fit in there for that number? 11. If you cross multiply and did all that, would it give you the same answer?
Yeah.
Yeah. So if that confused you the way I just did that one, then do the cross multiplying. Do the math.
6 over 4.
Slow down. And erase. What number is this? 8. Set up your proportion again. 2 blanks and an equal sign. Josh said 6 over 4. Everybody agree with that?
Yeah.
X over 8. This one I probably wouldn't even reduce because 4 times x is 4x. That's pretty easy. 6 times 8 is 48. That's pretty easy. Divide by 4. That's not too difficult either. What's 48 divided by 4? So I probably wouldn't even bother to reduce it on that one because it's pretty easy doing it out long ones. Number 9. Number 9, they want 2 answers, right? They ask
Black
you.
triangles are similar to
Identify the type.
Identify the segments. Look at the segments on number 9. Those blue segments that go in each triangle runs from a vertex to the opposite side, and what's it do at the opposite side? Forms what? Right angles. That's going back to this chapter when we did these big orange triangles. Which one goes from a vertex to the opposite side and forms right angles? That's the point where they all come together.
Or
Altitudes. That's your first answer. In that first triangle, that's an altitude. Those things that form right angles are altitudes. Altitudes. When you have an altitude in 2 triangles, if those 2 triangles are similar, then the altitudes are proportional just like the sides. So we're going to set up a proportion. Give me a side in the first triangle. 18. Side in the second triangle that it matches up to.
27.
Everybody agree with that? 18 to 27? Give me an altitude in the first triangle. 16. Altitude in the second triangle. We cross multiply. 18 times x is 18x. 27 times 16 is
432.
432. Now what? Divide both sides by 18. What's x equal? 24. Everybody agree with that? Look at it. Does it make sense for that altitude in that second triangle to be 24? Does that look feasible or sensible? Yeah. Number 10 goes from the vertex to the opposite side. Goes from vertex to the midpoint of the opposite side. Which of those things over there behind Mr. Brockman is it? Median. It's a median. Not mid-segment. My last class wanted to say mid-segment. Remember, a median goes from the corner to a midpoint. Mid-segment goes from what? Midpoint to midpoint.
How did I go?
Do what?
Finance. There's two.
Now we got to set this up. Tell me two sides that match up.
Y minus 1.
Y matches up to what?
Well, I did not write that, but 16.
So Y matches up to
I already
18.
done
18. Does everybody agree with that?
Yeah.
Y matches up to 18. So Y came from the first triangle.
Yeah.
What's the median from the first triangle?
Y minus 1
Y minus 1. So that's got to go on top.
over 16.
Over 16. Now watch closely. These are the ones, Brooklyn. Do this one in your head. Can't, right? All right, so you can't do this in your head. What you're going to have to do with this, and these are we're going to do more of these than we are of the easy ones. All right? First thing you're going to do, put parentheses around that. If it's got two terms in it, always put parentheses around it. Now, the reason I do that is because when I cross multiply, I'm going to write it like this. 18 parentheses y minus 1. Then I do the other cross multiplying. What's that give us? 16y. What do you got to do to start solving this? Distribute.
18.
Take that times both of those.
18y minus
18y minus 18.
That's it's all done now?
No.
Oh, okay.
So we're still solving it. Now what do we got to do? We got this big long equation. What do we got to do next?
16y.
Subtract 18y on both sides. Get all the y's on one side.
Negative 2.
What's left on the left-hand side?
Negative 18.
Be careful and make sure that's a negative 18. What's 16y minus 18y?
Negative 2y.
Negative 2y. Now what? Divide both sides by negative 2. What's a negative divided by a negative?
Positive.
Positive. You end up with y equals what?
9.
What'd they ask us to find? They asked us to find y?
Yeah.
So we should be done with that one. Y equals 9. Next one, number 19. Didn't hit next, but oh well. Number 19. I think this one deals with area, right?
Yes, let's find the area of the other polygon.
Remember with area, the only reason I'm doing this one's because I kept messing up on it. What do I got to do to this second ratio?
Square is
Square it. Area of the first shape, whatever shape it is, I'll need to know.
27.
27? Is that right? Area of the first shape is 27?
Yeah.
Area of the second shape?
We don't know.
We don't know. So
A.
X some aside from the first shape.
3 over 6.
3 aside from the second shape.
6.
Is that the only ones you could have picked, or did they give you others?
That's it.
That's it? There's only one pair that matched up? Now we're going to rewrite this. 27 over A equals, what do I do with this?
9
9
over
over 6.
Give that 2 to that 3, give the 2 to that 6. So 9, 3 squared is 9, 6 squared is 36. Now it's just a normal proportion. What do I do? Cross multiply. What's 9 times A give you?
9A.
9A, 27 times 36.
972.
Now watch, before I go any farther, 972. Because if I was doing this one, I would have done this. 27 over A equals that 9 over 36, I would have reduced that. Because what's a number that'll go into both those? 9. 9 will go into 9 how many times? 9 will go into 36 how many times? 4. Is that going to make it a lot easier to do the cross multiplying? Yeah, what's 1 times A? 1A. 4 times 27, let's see, 4 times 25 is 100. 4 times the 2 left over is 8, so 108. Do I really have to divide by 1 here? So what's our area of that second one?
108 feet squared.
Centimeters squared?
No, feet squared.
feet. Feet squared, 108 feet squared. Does it make sense for that second shape to have an area of 108? Should it have been more or less than the original shape? Looks like more, right? Yeah, those you're going to turn in as soon as I grab this paper up here so that I don't get them mixed up. Make sure your names are on those. You're going to lay them right here. Don't forget to turn them in. Make sure you put it up here. 3 points.
Then number 19 was 1A, 108 feet. L.
On the worksheets, that's your assignment. I know it looks long because it's like 4 pages, but most of them aren't that difficult. Notice on the first page, we got 2 problems. We don't have much time, so I won't be able to go over these, but make sure these tests get into your binders where they belong. Binders will probably be due here real soon. I'll put it up on the board here in the next couple of days. Yeah. Make sure these get into your binder where they belong. Who stole the extra worksheet that I passed down all these rows? Miss Pease, you keep 2 worksheets?
I heard it was dead.
Miss Pease, why would you keep 2 worksheets? Blake, do me a favor and grab on that top pile. Is that the big pile right here?
I need to open my eyes.
No.
The giant row.
Yeah, that. Grab that and hand it back here to Blake. The other Blake. Yes. Hoping it's not. No, these are not in the grade book yet because I didn't put them in there because of that worksheet.
Every time. Sheriff, so you sure you don't do this on purpose? 'Cause I felt pretty good about it.
Should have felt better about it after I made that deal.
Huh?
No, you keep them. Make sure they get in your binder where they belong.
What'd you say?
Should feel better about it. Big L?
That's a big one.
Well, I handed that to you earlier. You got questions over the test. Next time you can ask. So look over and make sure if you have questions. Because a lot of the tests from here on out will be just like this one.
I'm gonna do all the bonus.
Is that your computer back here? Or whose is that?
Like, you leave your laptop.
Yeah, you talk-